The next step in this video lecture is to make the PCB. And we start off by using the PCB wizard to create our outline. In order to do that, let's click on Systems, Files, and all the way at the bottom what you can see is the PCB board wizard. If your screen is not big enough, you can unfortunately not scroll this list, so what you have to do is just close some of these other ones up here and it will move up and you can see the PCB board wizard. Clicking on it, we get different options. We can select between imperial and metric. We choose imperial. We go as a custom board size, and what we want is that a board of probably about 2 by 1 millimeter should be 2 by 1 inch should be plenty large. So let's choose 2000 by 1000 inches. The rest of the settings you can read through them, but we will keep them as is. We actually don't want any power planes. These are internal planes that we only want a very simple 2-layer signal board. We want through-hole vias only. We don't have any kind of blind and buried vias. And we have surface mount components, not only through-hole components, but actually also surface mount. And we won't have any components on the bottom side. So you could say yes here, but in our case we actually don't do that. These are the default settings for the different trace widths, the spacing, and the default hole size for a via. We keep those two for now, and we finish it up, and Altium will actually open up our board. And this is it. The first thing we want to do is get rid of this white sheet. It looks kind of odd, and it's fairly simple to remove. You can go to Options, Sheet, and Display Sheet, and the white one is gone. The other one is we want to move the origin from the bottom here to the actual corner of our board. So we go to Edit, Origin, Set, and by hitting Control and using the mouse wheel, you can actually zoom in to the board and set the origin at the left bottom corner. Alright, next step is we have to actually save this PCB into our project. So if you go back into your Projects tab down here, what you can see is that this is for right now a free document and it's actually not part of our project itself. So we drag it and move it up in here so it's part of our project. And the next step is to actually save this PCB. And let's call it Homework 1 again. Alright, now that it's part of the project, Altium actually knows that this PCB can be linked to this schematic and the rest of the project. So what we can do is we can go to Design and import changes from the project itself into this PCB. And what this will do is it will find that many of the components we have in the schematics themselves are not in this particular PCB anymore right now, and it will add all these different components. We can validate them, execute them, and as you can see here on the right hand side now, these are all the components and pads that we have done. And this is the first time where you can see the different sizes of the different components. If you look at the switch, it's actually an extremely large switch that we chose here compared to even our microcontroller. And the pinout header is also fairly large. This red thing around here is a room definition, and you can find a tutorial on how to use rooms properly. In our case, we just delete this room for right now because we have no need for it. Alright, next step is to arrange these components on our PCB such that we have a good layout and that the routing of the different wires and the different connections that we see here becomes easy. A very good help is if you have your schematics right next to you. So either print this out and have it for you, or what I do is I grab the tab and I pull it out onto a different display on the side so that I have a reference where I can look at on where the connections go and what the different signals are. First, let's start with our most important piece, our microcontroller. Let's put it right into the middle. Next, we want to look at our switch that we have, and let's find a nice space here on the right hand side. Since it's so large, it's kind of difficult to do and place, so let's put it here on the left hand side. We then have our interface, and I think a good idea would be to put this here at the bottom so that all the signals are a little bit out of the way. And again, once you grab them, you can hit space to actually rotate them around. Now, As you have noticed that if you zoom in by hitting Control and your wheel on the mouse, you can see that there is a grid that's really small. And actually, if you look at the bottom here, you can see that the grid is currently set to 5 mils. If you hit the G key, you can get a choice of different grids, and especially if you place large components, a grid of 20 or 25 mils is probably a lot better because you have bigger steps and you can align things a lot more properly. So let's move our switch here. Let's move the microcontroller in the middle. Let's do the programming interface here at the top. And the other components we will move around too. All right, as you can see, I tried to place the components in a nice grid layout, which will make the routing later on, so filling out these different air wires that you can see here, significantly easier. Now comes one of the tricky parts. Our components C1 and C2, and if you can see is they just connect to VCC and ground. So this part wants to be close to this one here, but if you look around, they can make a lot of different connections. So where do we put them? Well, we certainly don't put them just out here on the outside in the vicinity of our PCB, because there they don't make any sense. If you remember, if you look at our schematics, we had C1 and C2 close by to our VCC pin line. So that's exactly where we want to put them. So again, we want to put C2, the bypass capacitors, close to this line here, and our C1 right behind it. With Control, we can zoom in so we can do a little bit of more precise placement. And with this, our rough layout is actually done.